Good morning.
Good morning.
Hey, we're finding the slopes of those lines. If you can try to see where they are, it's kind of tough. Maybe I can redo them. There's one of them. I missed. All right. And of course, you have access to the lesson too. So you can have that printed out in front of you. Okay, almost ready to begin in a few minutes here, 3 minutes. Participants are starting to join up, so just find the slopes of
Did you
those.
see the snap effect yet?
I didn't open up a Snapple today. I'm trying to drink water. Okay. Recognize the container?
The great.
Are you in my?
Did you know yesterday I had my birthday party?
Oh, happy birthday.
Thank you.
Not an April Fool's joke. It is true.
It is not an
Happy-
April Fool's joke. It is my birthday today.
Happy
Happy
birthday.
birthday, Apollo.
Happy birthday.
Thank you.
Happy birthday. Happy birthday.
Thank you.
It's a fool that looks for logic in the chambers of the human heart.
What?
You mentioned April Fool's Day. It's a fool that looks for logic in the chambers of the human. You're saying, oh, and I didn't even finish the saying. Like, oh, and the fool that looks for logic in the chambers of the human heart.
Oh.
Now, I don't know if oh means you got it this time because you thought you got it before I finished.
I thought I got it before you finished. I then understood.
It's a fool that looks for logic, and then you just stop there. So that wouldn't make that much sense. Unless, maybe somebody's really trying to get deep. Like, it's foolish to even search for logic. Oh, that's not what it's saying. It's a fool that looks for logic in the chambers of the human heart. Emotion and logic are two different things. That's what that's saying.
I'm currently wearing 2 pairs of headphones.
Okay.
One of them's covering my nose.
Hey, Mr. Rosenthal.
Hey, is for horses.
If you turn on my camera, I can show you.
No. Okay, we're almost there, folks. Almost starting. So hopefully you're finding the slope right now. We're up to 39, 40 participants.
Let's get to 60.
That would be great. You'd have to reach out, though, to those people. Say, come on, come join us.
Wait,
Let's
has
get 2,000.
It's the same people who are not joining. Those are people that prefer to just watch it later.
Let's get 7.9 billion.
or there are people that are just not watching the math at all?
All right, folks, mute yourselves. It's 10 o'clock. So here's what I'm going to say to you. Housekeeping. On Schoology, when you can get into Schoology, I put the invite in the materials folder. Okay, so instead of trying to scroll down in updates for some of you, now, what happens if you can't get into Schoology because it's down? So that doesn't work. So what you should do is either copy it into a Google Calendar. It has that in there. You could just click it and it'll put it in your Google Calendar. Or copy and paste the invitation into a Word document, all right, or into a Google document, or into a notepad, or on your phone, or on a piece of paper, or whatever, you know. So you want to have it so in case Schoology's down, you can still get into the Zoom meetings. 2, all retakes are today at 3, but really at 2:50, I'm going to have them in the Zoom folder. You can pick one. You can pick one to do. I don't want all of you doing them. Only those who absolutely needed to do it, you were planning on doing it before the break. So all of those that were planning to do it, there's a small group of you. It shouldn't be 100 retakes. If I get 100 retakes, I'm gonna have to sit there and think I might not be able to grade them all. It's just gonna be an overload. Okay, so you're only doing it if you needed to do it, not just for fun. Okay?
Did the Chapter 8 test grade come out?
I would have to have graded it. So all the grading is going to be taking place over spring break. That's when you should check daily to see if I've graded it. I have not begun any grading yet. Okay.
Okay.
I just caught up on all the homework grading, and your 10-week progress report grades are done. So now I can start working on your tests. Okay.
Mr. Ronco,
Mm-hmm.
for finding the slope for the orange graph, it's kind of hard to see where the dots are. Like
All right.
the first dot is in the middle, right? Like directly in the middle.
We don't say the middle, we say the origin. And the next dot is at
3 x
4, 3.
or is it 3x? Thank you.
Okay. All right. Now we can take a look at this. Okay, so the way that I do slope is I hone in on the coordinates and I look at the y values. The y values are the outputs. And I see that from 0 to 3, it's a jump up of 3. Okay. And then when I look at the x coordinates, that's a jump up of 4. And then I simplify, but that's already simplified. So the slope is positive 3/4. Okay. Any questions about that?
Wait, so you have to do the y over the x?
Outputs over the inputs. Yeah, change in y over the change in x. How is the output changing as the input is changing? Output is vertical, input is horizontal. So if I input a 2, I get a -2 for my output. If I put in a -4, I get out a 2. See how I'm moving the marker? I put in a -4, I get out a 2. I put in a 2, I get out a -2. I'm thinking of it as inputs and outputs. Okay, so what happened if I read these from left to right, let me go blue here, then let's look at my output of 2. I'm jumping down to an output of -2. Okay, So I'm dropping how many? I'm dropping 4, minus 4. See, I'm dropping down 4. Okay? And then I'm running over, that's my input, is negative 4 to positive 2 to get that drop. To get the drop of 4, I had to change my input. I changed my input by going from negative 4 to positive 2. That change is a change of positive 6. So down 4 over 6 simplifies to a negative divided by a positive is a negative slope. That's why you see the line going down from left to right. A positive slope goes up from left to right. And that would be negative 2/3. That's what the slope is. And then you hear them say rise over run. How much did it rise? How much did it run? Rise is talking about the change in output. Run is talking about the change in input. So for instance, this one in orange here, the rise was 3. It went up 3 spaces. It went over 4 spaces, plus 4, plus 3. Rise 3 over run 4. Rise over run is slope. Okay, it's another way to say it. Any questions about that? Okay, so let's go up above here and take a look at what we missed about slope. So I think we left off here. Okay, rate of change is what we were talking about. So you can have an increase or a positively sloping rate of change, right? Temperature going up over time is an example. You can have a negative slope, like we had here, where you get a decrease in the graph. It's going from left to right. It's the temperature's going down over time. And then what would no change look like? Well, in between up and down is straight, right? So that's no change. That means the temperature stays the same over time. Time is changing, right? The hours are going by and the temperature is staying put. Okay, so that's a flat line, is a 0 slope. What's a straight up and down line then? What would it, you don't see that here. Does that mean
Extreme increase in temperature?
that means the temperature is increasing, but no time is going by? Is that even possible?
Impossible.
Can the temperature change with no time passing?
No.
No. So that's undefined. There's no definition for that. Okay, so another way to get to that conclusion is if you think of a line that's going positive.
What was it?
Let's say the slope is 1. That's a 45-degree angle. If I make the slope 2, what happens to my arm? It gets steeper. What about if it's 3? Slope is 3. It's going up 3 for every 1 hour. Okay, it's going up 4 for every hour. What happens if I go 1,000,000? Look at what's happening. My arm is starting to go straight up and down, right? What if it's a billion, a trillion, right? It almost looks straight up and down. What if I go to a Google, where it's such a large number? You won't be able to tell it apart from a straight up and down line, but it's still not straight up and down. So what would straight up and down be exactly? That would be infinity. Well, that's not a number. So with straight up and down, if it's perfectly straight up and down, it's an undefined. But look at this. Why don't we just say that the slope is infinity then? Well, I'll tell you why. I can also get a vertical line by doing this. Here's a slope of -1, 45-degree angle, but going down. And then if I go -1,000,000, right? -1,000,000, and then I keep going down, right? And then what happens is you get a vertical line going down. That's negative infinity. Well, which is it? Is a vertical line positive infinity or is it negative? And you don't know. So there's no way to define that. And so
All three.
a vertical line is undefined. The slope is undefined. So you have 4 situations. You have a positive increasing slope, which looks like this. You have a negative decreasing slope, which looks like this. And remember, it's from left to right, because if I go back this way, it looks like it's increasing, right? But no, this is a decreasing slope. Okay, that means that the y, the output is going down as time is passing. And time is passing to the right. Yes?
You can also relate this as like a mountain climber, like if it's like straight, like a straight horizontal line, like a vertical line, I mean. Like if it's like straight, then the climber can't like go straight up to sky.
Yeah, but then you're going to get a student that has watched the movie Free Solo, the rock climber who can climb straight up, right? Then they're going to fool themselves out.
And that's undefined.
Yeah, I know, but they're going to fool themselves out of learning with that analogy. You're talking to somebody who's heard so many students come up with ways to not learn it, right? When students say, but what about this? And then that helps them to they help themselves to be confused, right? No, but I like the mountain climber analogy. All right. See, I poked holes in it before the other students could do it. All right, so slope in words. The slope, we're going to use m of a line passing through points. Now look at, what is this? x1, y1. What's the difference between x1, y1 and x2, y2? Why the two different things there?
They're different values.
X1 goes with y1.
Y1.
Right? It's a relationship between these two. But x2 it just means that it's not the same as that one. And that doesn't go with y1, it goes with its own relationship. So you have x1, y1, you have x2, y2. Given those 2 points, when you connect these 2 points, wherever they are, now if it's increasing, x1, y1 can be here, and x2, y2, as you input something that's to the right, more time passes, the output is more than the blue. That's an increasing example. So there, x1, y1 is below the other one. Or over time, it could be decreasing. So x2, y2 could be below over as time passes, right? Time is always moving in that direction, okay? Passes, the red point drops from the blue point, right? Or the third case, it's in the same, it has the same. So then y1 and y2 would have no change. So y1 and y2 could be equal if it's a flat line, so the slope is 0. And then you could say that what happens when x1 and x2 are the same, but you have different output. Then you have a vertical line and it's not a function, right? If you have the same x, right, the red has not moved to the right of the blue. No movement to the right. Then it just, and y changed somehow. Then you have 2 outputs for the same input value. So that slope would be undefined. Okay, you guys some of you need to mute.
Stop being
There's all
toxic.
sorts of noises coming out of your computers that are interrupting the lesson. Okay, so the slope m, we're going to call it m, of a line passing through 2 points is the ratio of the difference in y coordinates, which is the change in y, to the corresponding difference in x coordinates, which is the change in x. So how do we talk about how things are changing? Let's say I start with the number 2, starting number. You hear that noise?
Please stop being toxic.
I can't see who's doing that. Who is doing?
It's Ryan. That's Ryan.
Ryan, if you have to stop doing that, okay? It's very disruptive. I'll have to remove you from the session if you keep doing it.
Said his mic fell.
Okay, that's fine. Then it shouldn't keep falling.
That's just him breathing into the mic on purpose.
Okay, let's hold our comments. Thank you.
Dude, he was just tired.
No. Let's hold our comments. Let the teacher handle it. Thank you. Okay, so getting back to our train of thought, how do we talk about change? If I start at the number 2 and I end at the number 10, how do I talk about delta, which is change? Delta is change. How do I talk about how much it changed? Now, all of you know in your head, how much did it change from 2 to 10?
8.
How do you do that mathematically?
You 10 minus 2.
You do the ending point and you subtract the starting point.
Starting point.
Okay? So the ending point minus the starting point would do 10 minus 2, which would give you 8, which would be the delta. That's the change. Okay? So when we're talking about slope being the change in y, and it's a ratio of the change in y to the change in x, you're relating. It's a relationship. What? Hello?
Yeah.
Okay. All right.
We're
I
all
don't know,
gone.
some noise. There was some noise back there. So anyway, when we write this, you're going to see this here, what slope is. If slope is change in y, well, then it's if this is the 2 and that's the 10, the second y coordinate, to find out how much it changed, you would do the second coordinate minus the first coordinate. And that would be in a ratio to how the x changed, which would be the second x coordinate,
What lesson is this?
9(3), x2 minus x1. And that's
Which is really just the change in y over the change in x, except shown in a different way.
yeah, exactly.
What does M stand for?
Slope.
Oh.
Okay, delta y over delta x, dy dx.
Also, the y
One sec. Hold on, hold on. You keep going. You gotta wait for a second. In calculus, we say dy dx. D is for delta. Okay, dy dx is the definition of, or part of how we say the derivative in calculus. Okay, so a big part of calculus is the derivative, and so we're discussing the foundation of that right now. All right, remember, this is all leading to calculus and other types of mathematics. All right, any questions? All right. Now, it does not want x2 to be equal to x1. Remember what happened when these are the same, but you have two different outputs? Then what happens? You get a vertical line. You get no slope, no defined slope. Okay, so you don't want that what happens if you subtract 5 minus 5 down here?
You get 0.
You're going to get a 0. A 0 denominator is going to give you an undefined vertical line slope.
Because x hasn't changed at all.
Yeah. So what is an equation that says that x always has to be the same thing and never changes? It's simple. It's actually x equals some number. X equals a number is a vertical line. If x equals 5, x is always 5. And what would happen? That means x1 is 5, x2 is 5, x3 is 5, x4 is 5. All x's are 5.
That's always a vertical line.
And so it's a vertical line. If all the x coordinates are 5, then they will always be 5, and the y coordinates can be whatever they want, but x is 5. So then it just goes up and down only. Okay? So that's the equation. Looks like x equals a number. Now y equals a number is that other case where y never changes. If y never changes over time, you can always say over time, like the temperature does not change over time, that's okay. That's a flat line. So let's say the temperature is always 70 degrees and never changes, but time is still allowed to go by. As time goes by, it's still 70 degrees. So y equals a number. That means the slope, you can calculate it because time is x. As long as time changes, then this can be 0. 0 is a slope of 0. The slope of 0 is different than a slope of a vertical where it doesn't exist. So don't get those two mixed up. Not existing and 0 are two separate things. That's an interesting concept. All right, so that's slope. Now the next page down here talks about slope as a rise over a run, pictorial. Let me blow this up real quickly and then I'll take your question after I go over this part. There we go. So if you look up here, you'll see where could my first coordinate be? Now this is only one example of an increasing slope, a positive slope, right? Negative slope, then the slope would actually be a negative number. It would look like this, but here's a positive one. Here's your first coordinate. Here's your second coordinate, x2, y2. Now look, what is your delta y? It's your rise. if your rise is negative, what's a negative rise mean?
Going down.
Going the opposite direction. It's going down. So that's how we do negative slopes, is by saying we're rising negative amount, right? We're going that way. We're going down. Then your line would look like that. The red says that this has to take place based on your input changing. You cannot just change your y's. Your x's also are going to change. So you're going to bump over in order to go up, you must also move over at the same time. If you're doing them both at the same time, like on an Etch-a-Sketch, if you've ever had, you will go along this diagonal line. Okay? What is this difference? What is this change? It's y2, the ending y minus the starting y. What about for the x's? Delta x. It's the ending x minus the starting x. Gives you the change in x. Okay, so that's referred to usually as rise divided by run. Rise over run. Any questions about rise over run and slope?
I have a question. What's the difference between y1 and y2?
They're different locations, right? They're different heights. Y is the vertical axis, right? It goes up and down.
Yeah.
So if y1 is here, the next location for y came up.
Okay.
Right? So then y2 is above. So look at where y2 is. Look at where y1 is. Isn't this one up above y1?
Yeah.
It's also over to the side, isn't it?
Yes.
And that's because x changed, isn't it?
Yeah.
All right. If y changed and x didn't change, then this would be 0 down here. So you would just go straight up. Y would change up or y could change down. But if x doesn't change, to do that, that's like the temperature rising without any time going by. Not possible. The temperature could stay the same as if the time changes, the temperature could stay the same, but you can't raise the temperature with no time passing. That's a good way good analogy to understand that. Any other questions?
What lesson is this?
This lesson is 9.3.
Oh,
Yeah. Didn't you already ask that?
Is the rise over run to determine the length of the diagonal or the?
No. The rise over run does not determine length. And that's a really, really interesting question. So let's talk about that. Does a rise over run give you a length? The answer is no. So let's say that I have, this is 6 from here to here. And this is 8 from here to here. And this is straight up and down, right angle, perpendicular. Then this from here to here, the length of that is going to be 10 if I use the Pythagorean theorem. Okay, we don't have to talk about that right now. However, if I don't want to go from here up 8 and over 6 over, if I don't want to do that, I can go 4 up and 3 over. And then this length will be different. This length will be 5. So the lengths can change. All right? But the slope, what's the slope here? Up 4 over 3. What was the other one? Up 8 over 6, which simplifies to the same slope as the other one. So even though the length here is different than the longer length, the slopes are still the same. And what we know is that anywhere I put this point, if I go from here up to here and over, guess what that slope is? Even if it's fractions or a complex fraction. What happens when I simplify the complex fraction? It's going to always be the same slope. The slope is the same between any 2 points along the line. Okay? So pick any 2 points, this point here and this point here. If I go up and over, it's going to be some weird fraction, but then when you simplify it, it has to come out to 4 over 3.
So it's used to find the slope?
Right. The rise and the run is used to find the slope, not the length. Because the length depends on which 2 points you choose. The slope doesn't care what 2 points you choose. You can choose any 2 points and it will not affect the slope. The slope is the constant rate of change, isn't it? Yesterday we talked about the slope remaining constant. What happens if the slope does not remain constant? What happened to our line in yesterday's example? It breaks.
Curve.
It breaks, right. So the slope has to remain constant between any 2 points you choose. Then when you do a how far do I have to go up divided by how far I have to go over, it has to come out to 4/3 here, no matter what 2 points you choose. Okay? And the other, you guys are asking amazing questions. These are great questions for the lesson. Anybody else?
I could ask good questions.
Okay, slope. Okay, let's look at what this says. Slope is the ratio of the vertical change, we got that, delta y, to the horizontal change, delta x, of a line. It describes the steepness. That's another thing to talk about. Slope tells the reader, when I tell you the slope, it kind of gives you an idea how steep the line is, even if it's negative. Negative just means it's going down, okay? But the number that I give you, the magnitude of it, 5 versus 1, is a much steeper. -5 is much steeper than -1, is flatter. What about -1/2? What about -1/16? What about -1/1,000,000th? It's going to really flatten, not completely. What's happening to my numbers as I'm going -1,000,000th, -1 billionth? What are they getting?
Closer to 0.
Getting closer to 0. And what happens
Which
if
makes
0?
the line straighter.
Perfectly flat is 0.
Flat.
What about +1,000,000th? Now it's positive, but it's so
Slowly curving up.
Yeah, exactly. So steepness is something that slope describes. So steeper slopes represent greater rates of change. That means your slope has a bigger magnitude. Why do I say magnitude? Because it could be negative or positive, and it still affects the steepness the same way.
The distance from 0.
Yes, exactly. You're pushing that line away from 0. As you're pushing that line away from 0, that number is getting bigger and bigger. The number that the slope is talking about. Or the other way. Here's 0. Remember, 0 is a flat line. Okay? Then as you move up, the number of your slope, the magnitude of your slope is getting more. The steeper it gets. Okay? Less steep, or we say flatter slopes, represent lesser rates of change. So a slope of 1 is a 45-degree angle in a coordinate plane. So if I have a coordinate plane, if the slope is 1, that means when the input is 1, the output is 1. When the input is 0, the output is 0. When the input is 2, the output is 2. It's completely symmetrical. If it's completely symmetrical, then there's just as much space in here as there is over here. And if this is 90 degrees, right? Then what happens when you split 90 evenly?
45.
You get 40, yeah, right. So a slope of 1 is right in the middle. Any number less than 1, but still positive, if the slope,
not equal on both sides.
if the slope is less than 1, if m is less than 1, but greater than 0, so if m is between 0 and 1, you're going to get lines that are flatter than the green line.
Yes.
And if, now I think you know what I'm going to say, if the slope is greater than 1, then you're going to get steeper slopes. Okay? And then down here, I can go on. What is a slope of -1? That means for every input of 1, I go down 1. X is 1, Y is -1. I come down. Okay? When X is 2, Y is -2. I come down. And so what happens is you split quadrant 4 in half diagonally.
And it's still 90 degree. It's still a 90-degree angle.
Yeah, 45, 45 that way. These are negative. That's a slope of -1. And so now I can say, well, what if the slope is less than 0, but greater than -1? It's between -1 and 0. That's all of this stuff in here. Okay, and then if m is less than -1, that means less than, this is -1, you're going to go less than that is below it, right? So now you're going to get all of these, and these are steeper, okay? All right, what about over here? Well, over here is really these red ones, isn't it? These red ones come through quadrant 3, and the blue ones here, right? The blue and the red and the green all come down this way, right? So this is not different than this. These are just the continuation of these lines. And what about quadrant 2? That's just the continuation of these lines. So any lines that come through quadrant 2 going down through quadrant 4, those are negatively sloping. Even if they're up here, they're coming down. Okay, here you're going from quadrant 3, which is negative, but you're rising up through quadrant 1, so it's positive. Okay. The x-axis itself, the equation is y equals 0. Y is always 0. That's the x-axis. X is always 0. That is the y-axis. X is always 0. X is 0. X equals 0. Okay. I think we can move on. Any questions about that? Okay. Moving right along. Okay, go ahead and see if you get this. Here are the coordinates. See if you could take those coordinates and give me the slopes. Get nice and big. Find the slopes. The slope of the line that passes through each pair of points. Go. Take a minute. Go.
A minute.
I'm gonna go, while you're doing that, I'm gonna go clean the eraser.
April Fools.
I'm dropping out of school. April Fools.
Can you guys please stop talking? Because I'm doing it on the browser and I can't pin anyone, so I can't see the problem.
Oh, sorry.
Nice.
Yeah, I can still hear you guys. When I go in there, I can hear you. So
How? Magic? Mr. Rosenthal's a sorcerer.
Mm-hmm.
Math sorcerer.
I think it's just speakers.
All right, let's hold our comments, please.
Dark magic.
Some students like to use the formula y2 minus y1 over x2 minus x1. And they get their slope by just plugging it in. Totally fine. You should understand how to do it that way. So if you label these x1, y1, x2, y2, and it's been 2 minutes now, so we can go over these. Okay. Then to get the slope, I would take y2 minus y1 over x2 minus, careful here, what is x1?
-3.
Yeah, x1 is -3. Look at what happens here.
It's just +3.
See that? 2 minus -3. So you get 0 over 5, which is 0. This is a traditional way of finding slope. Mr. Rosenthal does not use this way.
Why?
Because I have a more intuitive way.
Because Mr. Rosenthal, big brain.
No. Okay, so listen.
And me, bigger brain.
Listen, there's by algorithm, that's it. That's by algorithm. By intuition, this is what it is. I know I'm trying to see how y is changing over how x is changing. So what I do is I look at my y, and I see no change. There's my numerator. I already got to the end right there. And then I look and I see, how did my x change? Well, from there to there, it went up by 5. And then I already got, so I'm going right to this step. I'm not writing a formula. I'm not plugging into a formula to get there. I go directly to there by just looking and seeing, okay, from here to here, it changed 0. From here to there, it changed positively. It went up by 5, and then I just simplify that to 0. Okay? That's how I do slope. You can do it either way you like. I suggest you start to try to understand it this way so you can quickly get your slope. Let's look at the second example. 1, 3, 1, 0. Okay? 3 to 0 is dropping by 3. See what I'm doing? 1 to 1 is no change, and my slope is undefined. A lot of students will say the slope is 0 here, and that's incorrect. This is the temperature is dropping by 3 degrees with no time passing. That's one way to remember that.
0 is defined.
Say that again?
Yeah, but you can't. 0 is defined, but you can't divide 0. You can't divide anything 0 by anything.
Mm-hmm.
Oh.
No, you can divide 0 by things, but you can't divide something by 0.
That's what I meant.
If x is the same on both, then it's obvious. Then it's automatically undefined. You can just do that.
Unless it's the same point, but you're not going to ever be asked. You're not going to be asked to find the slope between a point and itself. Okay, so you're never going to be asked that anyway. So it's not even something you have to worry about. But I like your way of looking at that is that pattern. Yes, if x is the same, it's undefined.
If x1 is.
By the way, so then okay, let's expand on that. What would the equation of this be? Of b?
What would the equation?
What is that number?
There's no
slope.
There's
But what's the equation if you said this is that vertical line, and remember on that other page, what is the equation of a vertical line?
It could be x equals a number.
What number is it in this case?
1.
X is 1. So the equation of this one is
X equals 1.
Yeah, now look at D. X equals 2.
Yes.
Undefined slope for D. See that?
Mm.
Look how quickly you can get an equation for the vertical line. There is no slope. Okay? All right, let's look at C. Oh, you can see now, look at what happens with the Y's. Okay, no change. The X's changed by 6, positive. The slope is 0. See, I just stopped using the formula altogether. I don't use the algorithm when the intuitive method is so much easier to use. But you are welcome to use the algorithm. This is the algorithm here. Any questions about this? I think I learned the Pythagorean theorem, but I forgot how to do the last part. So I'm gonna go look for it after the Zoom meeting. Okay, thank you.
I'm square.
I am unable to hear. Are you still unable to hear? Oh, wait, that wouldn't make any sense. If you can't hear me, could somebody text Tanya to make sure she can hear? She might have to log out and log back in again. Okay, let's move on. Yay, my favorite part. My favorite part.
Yay.
You'll be posting this on Schoology, right?
Yeah, yeah.
Thank you.
This will be due tomorrow before break. Would be great. In Schoology. Okie schmoky dokie.
Wait, what? What about testing break?
Well, tomorrow's the last day before spring break. So I would
Yay.
Yes.
Wait, really?
So we're not
I'm trying to
having.
pass along information, so you got to be quiet.
Are we in class tomorrow?
Guys, excuse me. I'm trying to pass along information, so you need to be quiet. Mute yourself. Okay. Homework. This is due tomorrow. In Schoology, under that assignment. Don't privately message me that.
Okay.
Put it in under the assignment. Okay? Any questions?
Wait the homework.
I have to put this in right after. So I'm gonna put it in a notepad right now myself.
Okay.
Notepad. The add. Math.
Wait a second, Mr. Rosenthal, when it says find the slope, you just find
Give me a sec, please.
the rate of.
Give me a sec. Give me 1 second. I gotta write this down. April 1st. Okay. Page 400, comma, 7 through 26 all. Got it. All right. Question.
That
Go,
was fast.
go ahead. Ask me. You have a question?
No.
Everett, question? Will we have class on Friday? No, we have no school Friday.
I meant tomorrow. Do we have class tomorrow?
Me saying we don't have class on Friday does not apply to anything else. It just is a comment on Friday.
Mr. Rosenthal, is that when your break starts? Have
What?
class tomorrow?
Okay, listen.
Mr. Rosenthal.
The break starts Friday. Got it? I'm trying to not answer the question directly. I want you to do, because I'm getting a lot of questions where you guys need to just think a little bit on your own, a little bit about what I'm saying. I don't want your brain to atrophy by me giving you every little thing, you know? So yeah, okay, I'm just gonna answer. Yes, there is class tomorrow. This is due tomorrow, there's class tomorrow, and then Friday we're off, and then we're off all next week.
Mr.
What's
Rosenthal?
the Pythagorean theorem?
Pythagorean theorem
A
is,
squared plus b squared equals c squared.
yeah, have you heard of a squared plus b squared equals c squared?
Also, Mr. Rosenthal, is
I think.
Assuming C is the hypotenuse.
Yeah, well, we're not doing that yet, but we can talk about that at another time.
And then you have to find the
Mr. Rosen-
square root of,
Yes.
in order to simplify
Question.
for just c, not c squared.
okay. For the final example, it says find the slope of the line. Does that mean just find the rate of change?
For which one?
For example, 493.
I just closed that down.
Fine, whatever.
Wait, what does it say? Find the rate of change?
Find the slope of the line that passes through each pair of points. Do you just graph the points?
No.
And then,
Find the slope means the rise over the run. It's what the whole lesson was about, that one topic, slope. So the lesson was rise over run, slope. We had that algorithm that gave you 2 points. We found the slope between the 2 points.
oh, okay, so it's just like the rate of. Oh wait, no, never mind.
What lesson is-
No, you're right. You're correct. It is the rate of change. It's
Wait,
the
what
constant
lesson is
rate of
it?
change. The constant rate of change. You guys, please stop interrupting. It makes it very difficult for the students to understand and for me to actually deliver it. So just hold on 1 second. So you're absolutely correct. The rate of change, the constant rate of change is the slope. They are one and the same thing.
Huh? Okay, that's just what we did yesterday.
On tables, is it y over x?
Oh yeah. Okay.
It's the
never mind.
change in
Thank
y.
you.
It's the change in y over the change in x, not y over x.
On tables? Okay.
What tables? What?
Like on a table, if it's like flat, would it be y over x? Like,
Oh, if it's proportional, then each y over each x will match the slope.
okay, but it's like y over x.
Change your name. Your name is now
But-
Ryan Lewis.
But yeah, if you guys are changing your name and I catch it, I'm just going to remove you without warning. Okay?
Mr. Rosenthal?
Yes.
I'm sorry, you go first. You go first.
Okay. I was just wondering how many lessons were in the chapter so I could print out the review before we reach the end.
Oh, I don't know, but they're all in Schoology. So if you just go into Schoology to print them out, all the ones that there are there. I believe it's
Okay.
9. I think it's 9-7. I think so.
Okay.
Wait, what lesson is this again? 397
9-4.
or 9?
Which one? The one we just finished, or the one we're about to do?
We're on 9-4.
We're about to do.
The one we're about to do is 9-4.
Okay, thank you.
And the problem is up there. So let me read it. Graph a line that shows a 3-unit increase in y for every 1 unit increase in x. State the rate of change. That shouldn't take too long.
Rate of change is slope,
Hold
right?
on. You can, yes. And you can put the answer in the graph. You can't put the answer, but the state the rate of change, that you can put in the chat.
Can we put the first value for x like anywhere? Or do we just?
I don't know.
Because-
Can you?
Yeah, I think so because it says it's increasing.
So now what you're getting into is what Mr. Knaus wants you all to learn eventually is transformation. And specifically, a translation.
I have a new algebra teacher next year.
Hold on one second. Taking a line, I can move this line up. I can move that up to there. I can move that same line down. Okay. I can move that line over to the right. Actually, I'll show you something that's cool. Sometimes you cannot distinguish between me moving it over to the right and moving it down. You can get the same result. Or moving it to the left. If I move this green line to the left, it can actually match up with the pink line. Okay, so I can move this line over to the left, up or down, and that's called a translation, and the rate of change stays the same, which means that all these lines are parallel. It doesn't change the slope. So the slope stays constant even if I translate the lines up, down, left, or right. Okay? That tells you something about, you are free in this equation that you're going to make to change something. So you can get all kinds of equations out of this. All right, so let's do a graph. The easiest case, I think, is that if you start at the origin, and now from there, so the question was, can I start anywhere I want? Yeah, I could start wherever I like, because this talks about just the change. It does not talk about the location. All right, so it did not say that I had to be in a specific location. I could be somewhere out here. That could be A, and B could be somewhere over here, and it's not even on a coordinate plane. Okay, it's just changing, increase by 3, the Y, and increase the X 1 only. So it looks like that. So the line looks like that. Okay, now I'm going to do it on a coordinate plane. 1, 2, 3. Go up 3 over 1. So then this coordinate would be 1, 3. There's the line that would go through them. Okay, so I would say the rate of change is what, everybody? Delta y over delta x. If the y changed by 3, the x changed by 1, simplify 3 over 1.
3.
So the slope or the rate of change is 3. Notice how it's not right in the middle. Slope of 1 is right in the middle. Anything above 1 is steeper. So notice that the slope of 3 is steeper than right in the middle. Okay, now how would I move this line up? Or let's actually, what equation can I use for this line? Y equals mx plus b, right? y equals the slope of 3x. And where did we start? It went through 0, 0. So it's just y equals 3x. If I add or subtract on the end, if I add, let's say, some amount, c, and c is positive, this line moves up. If c is negative, the line keeps the slope and moves down. How do I move it over to the right?
Multiply it by something.
If I multiply this, what happens to the slope? It will make the line steeper. So we call that scaling. So we would scale the line steeper or flatter by changing the slope. So if I multiply this by something or divide it by something, the x, it will steepen it or flatten it. If I add something on to the end here, then it will lift it up and down. But how do I keep the slope the same and move this over to the right or to the left? Can anybody figure that out?
But Mr. Rosenthal, these are the same things that I've been doing with the parabola, correct?
Yep, it's the same no matter what shape. This could be a circle. This could be a parabola. It could be an ellipse. It can be a sine wave function. It could be this, right? It could be any picture that shows up, any weird looking thing that shows up, and the transformation doesn't change in the equation. Moving it up, moving it down, moving it left, moving it right, making it scale up or scale down in steepness, that all is done the same way no matter what type of object it is on there. So no matter what, adding on to the end will always bump whatever the picture is up, even if it's a circle. Adding on to the end will move it up. Subtracting off the end will move it down. Okay? Multiplying the x term by something or dividing it by something will make it steeper or flatter. Okay? But how do you, the only thing we haven't talked about is how do you move the line to the right or to the left?
Would you like?
The question was, by the way, while we're thinking about that, somebody said, do we directly message you the test once we retake? For today's retakes, yes, you will directly message me your uploaded retake. Okay, but for tomorrow, tomorrow is the makeups for those that missed the Zoom test for Chapter 8. Those you can still submit in Chapter 8, under Chapter 8. Okay, all right, so who's going to answer how to move this line to the left or to the right?
To
Divide?
+1.
to move it up, you have to have a y-intercept, but to move it up and down, you add and subtract. So does that mean you have to multiply and divide to move it to the right and left?
It would be
Multiplying or dividing the x by anything is going to make it steeper or flatter.
Would you add to the x instead of add to the, or no? You would
wait, what?
add to the x instead of adding to the y.
We are adding to the x.
So let's do this. Let's come back to what we have now, right? 3x.
You do.
What can I do to that, which is what we're looking at right now? How do I change that to bump it over? Let's say just bump it to the right one.
Isn't it
3 parentheses
Isn't it
+1.
I know we did this with the it's on Mr. Rosenthal with the parabola stuff I've been doing. Would I just remove the x squared on all of the equations?
You could, to think about it in terms of this way, yeah.
So
how
then
would
I
you do
think it would be 5x + 1. Or
What if I did this? What would happen?
be 3x - 3.
If that happens, what happens to my line?
I think it would move over to
The 3x would be the same. The 3x would be the same, and it would move down 3 spaces.
yes.
Okay, so 1, 2, 3. This point moves down to there. This
Which
point moves down to
cause-
there. Look at that.
Yeah, it would cause it to move over.
Remember what I said about moving down and moving to the right can give you the same line. Okay, but I just did it in two different ways.
So adding it would move it to the left.
I could have just skipped this step and just subtract 3 from here. Then you're moving it down 3 spaces. Each point down 3, down 3.
Yeah.
But if I do this way, I have bumped it to the right. This point, I moved it to the right 1. You could think of it that way. So if I want to move something right or left, I have to put parentheses around the x and add or subtract to the x. Adding or subtracting to the x moves things left or right.
Yeah.
Okay? Now,
if you added it, would move it to the left.
Then I would think, well, then adding or subtracting to the y moves things up or down. How is this adding or subtracting to the y? Well, go ahead and add 3 on both sides. Add 3 on both sides.
It'll be y plus 3.
Y plus 3 and 3x. See that? That is adding. I am adding or subtracting from the y gives me vertical movement.
Yes.
Okay? So you can see it that way. Now this is very complex, but it is where you are headed in mathematics. But that's enough for right now. Let's do one more. I have a lot of these warm-up problems. So let's go ahead and get into one more, and then we'll call it a day after that. Name 2 points on a line that has a slope of 5/8.
I haven't unmuted this entire time.
What?
Never mind.
Sorry. What was the question?
I just realized that I was just unmuted the entire time.
Okay. How will we know if we have to retake if you haven't posted the grade yet? Posted the grade on what? You can retake anything that you have.
I think they're saying the chapter 8 test.
No,
they're confused.
The retakes are not available for chapter 8 yet.
Yeah, it's only
Chapter
for
6.
Retakes are only available for 5, 6, and 7.
Yeah.
Did I grade chapter 7 yet?
Yes,
so.
I think so.
Yeah.
Probably.
So you can retake 5, 6, or 7.
Hey, Mr. Rosenthal?
Uh-huh.
Have you been working on the chapter 7 quiz?
I'm sorry?
Have you been working on the chapter 7 quiz?
I have not worked on any grading.
There was no chapter 7 quiz.
I graded the homework. I put in your 10-week grades.
Oh, it was the chapter 8 quiz.
And over spring break, I will be getting all those grades in.
Okay, thank you.
All right. Name 2 points on a line that has a slope of 5/8.
I think I already have.
The easiest way to do this, by the way, is to use what starting point?
The origin.
Yeah, the origin would be the easiest way.
0, 0, and 5,
Yeah.
8.
And now you're
It would be 8, 5.
x2, y2. You just have to make sure you get a slope. So the trick is, do you know what the 5 is? Is that delta y or x?
The 5 is delta y.
Yeah, delta
Yeah.
y.
Oh, so yeah.
5.
Yeah, it would be 8, 5. It would be 0, 0, and 8, 5.
Right. So you want this distance to be 5. Now I could go down. I can go down to -5 as long as I go down to -8. What would -5 over -8 be?
It would still be a positive.
That would be positive 5/8. So I have choices here if I start with 0, 0. I didn't have to start with 0, 0. Okay? But in order to get a slope of 5/8, your change in y has to be 5. Okay? So if I made this a 1, then I'm either going to go up to 6 or down to -4. I'm going to change it by 5 somehow, in one direction or the other. Okay? But it's easier to just go from 0. 0 up to 5 would be a change of 5. Going from 0 to 8 with my x's would be a delta x of 8. Okay? So these 2 coordinates would work. There's an infinite amount of combinations you could use. I am open for office hours now. Dismissed.
Thank you.
Thank you.
Thank you,
Bye,
Mr.
Mr. Rosenthal.
Rosenthal.
Okay, remember,
Rosenthal, thank you.
250 chapters 5, 6, and 7 retakes will be available at 250 today.
Thank you, Mr. Rosenthal.
Thank
Did
you.
you already grade the chapter 7 tests?
Yeah,
I believe so.
he did. He gave it to us like way before.
Yeah, look in Schoology. It'll be there.
Yeah.
Mr. Rosenthal,
Yes.
where will we find the retakes?
In the Zoom test folder.
Hey, bye, Mr. Rosenthal.
Goodbye.
Thank you, Mr. Rosenthal.
Thank you.
Bye.
Bye-bye.
Bye-bye.
Bye. I'm open for any questions.
Mr. Rosenthal?
Yes.
My dad and I had a question about one of the problems on one of the homework assignments.
Okay.
It was here, let me grab the book. I think it was like something of
Tell me the page. I have the book.
yeah, I think it was like 393.
Okay.
393. No. Well, wait, hold on. Yeah, it was one of the other ones. The question was like find
I have the book, so if you tell me the page, I can go right to the problem.
Yeah, I'm trying to find what it's probably in my homework. In my notebook.
Or if you remember the problem. But if you don't remember the problem.
It was sorry. I don't think. Hold on. Oh, did I just miss it? No, I don't know exactly which page it was, but I think it was. Hold on.
In the current chapter we're in, right?
I think it was page.
It's either 9-1 or 9-2.
Yeah, it was page 377. The question 36 says the one about the rectangle. Find the minimum dimensions of the rectangle. My dad and I were a little confused about that.
What number is that?
Number 36.
The perimeter of a rectangle is at least 50 centimeters. Greater than or equal to 50, right?
Okay.
Okay. The length of the rectangle is one more. So the length is one more than, see that?
3 times the width.
3 times the width. There's 3 times the width plus one more, and that's what the length is, right?
Yeah.
Okay. What are the minimum dimensions of the rectangle? Well, perimeter is made up of 2 lengths plus 2 widths, right?
Yeah.
And that has to be more than or equal to 50, at least 50.
Mm-hmm.
Okay. And then I know what L is. So instead of L, I'm going to substitute that L is 3 W's plus 1. And you're going to have 2 of those, right?
Okay.
Plus the 2 W's, greater than or equal to 50.
Mm-hmm.
Now you'll have 6W plus 2 plus 2W, greater than or equal to 50. So 8W plus 2 is greater than or equal to 50. And then 8W, if you subtract 2, is greater than or equal to 48. And then to divide by 8, 8W is at least 6. The width is at least 6. Now let me look at the question. What are the minimum dimensions of the rectangle? Well, the minimum, the smallest that this could be, would be 6, right?
Yeah.
Okay, if the width is at smallest 6, plug it back in here. 3 times 6 is 18, plus 1 is 19.
L equals 19.
Yes.
So the minimum dimensions would be 19 and 6?
I would think so.
Okay. Thank you.
Yeah, because if the width is as small as it can be, okay, then the length would be 19. The length has to be, let's see, but if you made the width, oh yeah, the perimeter. Yeah.
Okay.
Yeah,
Thank you.
that is the smallest that the width could ever be. Yeah.
Thanks.
Okay.
Thank you.
All right. 16
See you
and
tomorrow.
6 and 19 are the solutions.
Okay, thank you. See you tomorrow.
All right, you got it.
Is there a vocab for the retakes?
Probably.
Okay.
Okay. Good question. Anybody else? Any other questions? Do me a favor to show me that you don't have any questions. Go ahead and log out if you are done, but you're more than welcome to stay on and ask me any questions. And that way I'll know when we're all done. Peyton, you have a question? Nikhil, Madison, Ariana, do any of you have any questions? Peyton, Madison, any questions?
No.
No? Okay. I will see you tomorrow. All right, Peyton. See you later.